A porter gown has equal arms, each 250 millimeter long, right? Equal arms of both are 250 millimeter long, all right? And pivoted on the axis of rotation. Each board has a mass of 5 kg, right? So here we have a board that is 5 kg, and the mass of the central load is 25 kg. So central load that is 25 kg. The radius of rotation of the board is 150 millimeter when the governor begins to lift. Right? So at first stage, when the governor begins to lift, the radius is 150 millimeter, and 200 millimeter when the governor is at maximum speed. Right? So this is incident 1, this is incident 2. Right? So at one stage it is 150 millimeter, right, when the governor begins to lift, and at maximum speed that is 200 millimeter radius. Right? Find the range of speed, sleeve lift, governor effort, and power of the governor in the following situations. First one, when the friction at the sleeve is neglected. Right? So here we don't have a frictional force. Second case, when the friction at the sleeve is 10 Newton. Right? So here we have a frictional force which is 10 Newton. Right? So we'll first extract the data from here. Given BP is equal to BD is equal to 250. Right? BP equal to BD equal to 250. Why? Because it's given it has equal arms, 250 millimeter. M is equal to 5 kg. Why? Because the board has a mass of 5 kg, and sleeve's weight is 25 kg. So capital M is 25. Right? And when the board begins to lift 150 millimeters, so R1, right? At point 1, 150 millimeter, that's here. And at point 2, at the maximum speed, it is 200 millimeter, right? So R2 is 200 millimeter. Okay. For the second part of the question, the frictional force is 10. Okay. So for the first part, we don't need this. All right. So we have to find the range of speed, sleeve lift, governor effort, and the power of the governor. All right. We'll start finding it. First of all, let us find the minimum and maximum speed of rotation, because only the radiuses are given. From the radius, we can find the minimum and maximum speed. Right? So we can apply the Pythagoras relation here. This is 150 millimeter given in the question, right? Radius. This is 250 millimeter, the length of arm, which is also given in the question. So from these two values, we can find the H1, that is BP squared minus BG squared will give you the BP squared, GP squared. Right? So H1 is equal to under root of BP squared minus BG squared. Right? So BP squared is equal to 250 whole squared. BG squared is equal to 150 whole squared. Under root of it, which will give you 200 millimeter. Right? So H1 is equal to 200 millimeter. All right. Similarly, we have to find the H2 also. So H2, right? This is H2 at maximum speed. So at maximum speed, the arm will not change to 50 millimeter. The radius is 200 millimeter. Right? So 250 whole squared minus 200 whole squared, which will give you 150 millimeter. Right? So under root of BB squared minus BG squared will give you the H2. So under root of 250 squared minus 200 squared will give you 0.15 meter. Okay. So now we have found the heights at both the incidents. Okay. So from these heights we can find the N RPM, right, from equation. So we'll simply apply to the equation N1 squared, right? N1 squared at the position where R1. Right? So N1 equal to small m plus capital M upon M into 895 by H1. Right? So small m given 5 kg, capital M given 25 kg, small m again 5 kg, 895 number, H1 we have already found 0.2. So which will give you 26,850. Right? If n is equal to 26,850, we know n1 equal to 164. Right? Why? Because here it's n squared. Right? Here n1 squared is equal to 26,850. Therefore, n1 is equal to 164 RPM. All right. Similarly, we will apply it in the equation for n2 to find the maximum speed. Right? To find the maximum speed, n2 squared is equal to small m plus capital M by M into 895 by n square, H2. Right? So we'll replace the values here. Right? Small m, that is mass of the small ball, given 5 kg. Right? Capital M, that is sleeve, 25 kilogram, mass again 5 kilogram into 895, that's number. H2 we have found here 0.15. 0.15. So when you solve it, you will have 35,800. So N2 squared is equal to 35,800, which means N2 is equal to 189 RPM. You just have to take proof for this 189 RPM. Okay. According to question, we have to find the range, sleeve lift, ground effort, and power. Okay. So first we will go for the range. We know the range is N2 minus N1, right? Simply N2 minus N1. So N2 we have already found 189. N1 is 164. So 189 minus 164 is 25 RPM. So that's the range. And then we have sleeve lift. All right. You know that the sleeve lift X equal 2 into H1 minus H2. Why 2? Because there is an arm and there is an arm. So 2 arms. Right. So here H1 minus H2. Here H1 minus H2. So 2 into H1 minus H2. Right. So 2 into H1. Right. H1 we have found 0.2 minus H2, that is 0.15, which is equal to 100 millimeter, that is 0.1 meter. 2 into 0.2 minus 0.15, that is 0.1 meter. So this is the sleeve lift. All right. Then we have governor effort. Okay, governor effort. Let's see the percentage increase in the speed. All right. C is the percentage increase in the speed. We know the initial speed. We know the maximum speed, but we don't know how much is the percentage increase. Right? So we'll calculate this first. We know that the increase in the speed of the range of speed C and 1 is equal to N2 minus N1. Right? So N2 minus N1, that is the range of speed, that is 25 RPM. Okay, 25 RPM. We need to know how much is that percentage. Right? So percentage is C and 1. Initial speed into C, that is percentage. So C and 1 should be equal to this range. Right? C and 1 should be equal to this range. Why? Because the range is the maximum speed minus initial speed. C is the percentage of the increment. Right? So N1 into C would be the maximum output, right? Or maximum speed. Initial speed into some percentage will be the maximum speed. So C into N1 is equal to N2 minus N1, which is equal to 25 RPM. Okay. We don't know how much is the C, but we know how much is N1. How much is N1? N1 is 164 RPM. Right? So C into 164 should be equal to 25. Right? So C into 164 equal to 25 means C is equal to 25 upon 164. C is equal to 25 upon 164, which will give you 0.152. Okay. So now we have found the C. So if you know C, we can directly apply in the formula. You know that the governor effort P is equal to C. We have already found 0.152 into small m plus capital M into G. Small m5, capital M25 into G 9.81. Okay. That is equal to 44.7 Newton. Alright. So this is the governor effort. And the power of the governor. Power of the governor, I told you, the effort into sleeve movement X. Right? We have already found the power, not power, governor effort. We have already found the sleeve lift. So power is the multiplication of this term with this term. Right? So power is equal to P into X, that is 44.7 into 0.1, which is equal to 4.47 Newton meter. Right? So this is the power. Right? So when you are doing this type of task, numericals, please pay attention to the unit. Okay. So if you ask the power, okay, you must end up with some kind of Newton meter over something like that. Right? So if you are end up unit Newton only here, that is not power, that is force. Right? So you need to recheck if you have missed something. Right? If it is governor effort, you should get a unit Newton. Right? Because effort is force. Right? Then you should end up with the term Newton. If you have Newton meter here, then there is something wrong. Right? You need to recheck. So it's better you carry the units along while you are doing. That would be easy to cross check whether you have done the correct, and whether you have answered the correct point. If the power is asked, and if you respond to it in an effort, then that's wrong. Okay, so please pay more attention to it. Then the second condition, when the friction at the sleeve is equivalent to 10 Newton, you have to find all this stuff. This time, speed of range of speed, sleeve lift, governor effort, and power of the governor. So we need all these four things. If the friction is 10 Newton. Okay, right. So we do it again. Same formula, just accommodating the friction. So N1 squared is equal to small mg plus capital Mg minus F upon Mg into 895 H1. Why minus? Because now the sleeve is at initial position, right? So which means there is no upward movement. So in that case, the friction will act upwards. So there's minus F into 895 upon H1. Okay, we know all these terms. We just have to replace, right? M5 small m, that is mass of the ball, G gravity 981 plus capital Mg, that is 25 is sleeve weight, into G 981 minus F is given 10 Newton upon small mg 5981 into 895 number upon H1. H1 we have already found here, that is 0.2 meters. When you solve it, we will have 25,938. Okay, so in 1 square with friction is 25,938. So when you solve it 0.1, we will have 161 RPM. Okay. Similarly, we will do it for N2, right, at the maximum speed. So at the maximum speed, we know that governor will tend to move up, and therefore the frictional force will act downwards, and therefore we are adding it with mg, right? Capital Mg is in downwards. The force will also try to tend to act in the downwards direction, therefore plus. Right? So small mg plus mg plus f upon mg into 895 H2. Right? You know all these terms. We just have to substitute, right? So small m, that is 5 kilogram, G 981 plus capital M, mass of the sleeve 25 into G 981 plus F, if it's given 10 Newton upon mg, right? M small m 5, G 981 into 895 upon H2, right? H2 we have already found, that is 0.15, right? H2 we have found 0.15, right? 0.15. When you solve it, you will have N2 square is equal to 37,016. Okay. So if N2 square is equal to 37,016, you can find N2 is equal to 192.4 RPM. Okay, now we have N2, we have N1. So now we have to answer these questions. What are the questions? To find the range of speed, sleeve lift, governor effort, and the power. Okay. First, range of speed. We know the range of speed is N2 minus N1. So N2 is 192.4 minus N1 is 161. So when you subtract it, you will have 31.4. Right? 31.4 RPM. Second thing, sleeve lift. Right? Sleeve lift, we know sleeve lift, that is x will be same as calculated by y, because there is no change in the sleeve lift. Right? It's not affected by the frictional force. Right? 2h1 minus h2. Right? We have already found h1 is 0.2. Right? H1 is 0.2 and h2 is 0.15. Right? So these h1 and h2 are not affected by the sleeve lift. Right? They are not affected by the sleeve lift. So we don't need to worry about that. So therefore, sleeve lift is equal to 0.1 meter. No change in this. Governor effort, right? Governor effort. Okay. So governor effort is, let's see percentage increase in speed. So similar thing, right? For the governor effort, we know what is the speed N1. We know what is the speed N2, but we don't know how much is the C or the percentage, right? So we have to find the C. So C into N1 equal to N2 minus N1, right? C is the percentage increase in the speed. N1 is the initial speed, right? So N1 into percentage increase of the speed will give us the range of speed, right? N2 minus N1. We know N2 minus N1 is equal to 31.4, right? We have already found N2 minus N1 is equal to 31.4. From this we can find the C, right? From this we can find the C. So C into N1 should be this value. So C into N1, that is N1, 161, right? C into 161 should be equal to C into 161 should be equal to 31.4, right? So C means 31.4 upon 161. C equal 31.4 upon 161, which is equal to 0.195. Okay. So now we have found C, which is equal to 0.195. All right. We know that the governor effort P is equal to C into mg plus capital Ng plus F. Right? So we already have that formula here. Right? C is equal to capital Mg plus small mg plus F. Right? So C I have already found, that is 0.195 into small mg, small m5 into G 9.81 plus capital Mg, right? Capital M 25 kilogram into G 9.81 plus F, that is given 10 Newton, right? The post 10 Newton. Right? So when you solve it, you will have 57.4 Newton. Okay. So the governor effort is 57.4 Newton. Okay. If we know the sleeve lift and governor effort, we can find the power of the governor, right? We just have to multiply this term with this term, right? So we know the power of the governor is P into X. E we have 57.4, X we have 0.1. So P into X is equal to 57.4 into 0.1. Okay. So when you solve it, you will have 5.74 Newton meter. Okay. So the power of the governor is 5.74 Newton meter.